This is the Python dynamic programming solution for 1235, LeetCode 1235. And in this problem, we want to find the max profit for a job taker who can only do things serial. So he cannot do two jobs in parallel. So no overlapping jobs. And so in this example, when the blue job ends, he can take the purple job, and that will give him the max profit of 120. And in the solution, this is what I did for implementation. So we want to use dynamic programming. We want to know, like, this is a good time to use dynamic programming because the end time and the max profit on that end time can be used to calculate the max profit at the next end time. So we want to first sort. We want to ascend the end time. So sort with ascending end time. And the way that I did it here was I used zip, I used sorted, these two Python functions, zip and sorted. And Python's a really beautiful language. And this is what it kind of outputs here. So you can see like the zip, it would first, so if you put in 3 lists into zip, then it'll output, like it'll take like the values at the first index and output it, the values at the second index and output it, and then so on. And then I also sorted it. So I sorted it by the with a function that looks at the first index of each tuple. So this is my way of representing each job with ascending end time. It possibly faster if you just use list. But I wanted to make it very readable and like understandable for somebody who is like more high level managerial. So we want to use a job scheduling memo. And for dynamic programming, we have a max profit for each end time, right? So we set for each end time, we set the max profit at 0 to start out, and then we loop through all the jobs, right? All the jobs and each job we extract out the start, end, and profit. Then we consider 3 conditions. The first condition is we took the job. The second condition, we did not take the job. And then the third condition is we took the job and we want to see if there's any job before that is compatible with this job. So job plus previous compatible jobs, right? And then, yeah, so, and it's very interesting. So the first 2 steps, the first 2 situations, we took the job, we update the memo, we did not take the job, we update the memo. And then this is the interesting part where we did a binary search. So this is what you want to do. So you want to do a binary search because if we were to look at all the jobs that is compatible with this current job, then that would be order n squared. But if you were to just pick a job, like let's just say a midpoint, you just pick a job in the middle, and then we see if the end time is less than this current job's start time. And then if true, then we just update our left index, right? We update our left index, and then if not true, we also decrement our right index to that midpoint, right? So then we stop the stop the while loop when the left index is adjacent to the right index, and then when that stops, we have the left index will be where will be the job with the end time before this current job start time, right? So it will have the last end time before this current job start time, and then we use the last end time. We'll use the last end time, and then we get the max profit for the last end time, and then we add this job's profit with this max profit, and then we compare it with whatever we stored at the max profit at this end time. So it's interesting. So this is how we updated this end time. We update it with profit plus profit at last end time, and then we just return the profit at the max end time that our jobs have. So this is our last job, and then this will be, you know, the end time at that job, and so that would give us the max profit. This will give us the max profit, and this is some of the outputs for some of the test cases. So I try to put in two different test cases. This is another test case where this has overlapping end times, so that's pretty cool. Just make sure everything's working. And then this one is what test case that they gave. And so this is good. Yeah, this is pretty robust. And yeah, I just, you know, this code here, I try to write everything out, and SNL1 means Sentinel 1. Some people, they just write left and right, but I think Sentinel has more of a meaning because that's what stops this while loop. And so yeah, I hope this is very understandable. It took me about one night like to figure this out, and when I slept on it, then I realized like what everything meant, how everything should be done. And yeah, I hope you enjoyed it, and see you next time.